Bismillahirrahmanirrahim. Okay, guys, let's discuss the difference between a sector and a segment. If you look at this circle at the left of your screen, you see that there's the center O, here is A, and here it is B. So this is the region bounded by the radii and an arc. For example, if I call this the region X, okay, and this is the region Y over here. So this X is representing, this one is representing the minor sector, okay? This one is the minor sector. And this one is here, that is the major sector, okay? The major sector. So that is the main thing, that the region bounded by the radii and the arc, that is called a sector. If you look at the right side here, now this is, if I call this the, let me call this point P, this point Q. Here is the region, this is the region U, okay, and this is the region V. So uh, the region which is bounded by a chord and an arc, that is called a segment. The region bounded by a chord and and an arc, that is called a segment. Like this U is representing a segment here, V is representing a segment here. So this is your minor segment over here. Okay, this is the minor segment. And this one over here is the major segment. That is the major segment. Okay? So that is the main difference, that what is a sector and what is a segment. Acha, now there is an interesting thing over here. Sometimes look at this, let me draw a line here. Like if I draw a line here, let me draw the line like this. If I draw a line here, you see that within the sector X, let me erase this thing. Acha. Now, look at the minor sector OAB, minor sector OAB. Now, within the sector, there is the segment. Like if I shade this, this is the segment over here. So all of this, let me shade this, all of this as yellow, okay? Now the yellow region is representing a sector and the brown shaded region is a segment. So a minor segment, you can note it down that a minor segment lies inside, inside a minor sector, okay? A minor segment, a minor segment lies inside a minor sector. Now let me show you here now. For example, if I just remove these things from here, okay, and I try to show you the center here. For example, here is the center, okay, and here is the center, okay. Now this, look at this, you will really like this. Now if I shade this one, so I'm shading the major the major sector, that is shaded green, okay. And look at this, I'm shading, now I'm shading this blue. So what should I call this blue region? Isn't that the major segment? So this time, the major sector is inside the major segment. Okay? So you can say that a major sector, a major sector lies inside, a major sector lies inside a major segment. You see, this is so confusing, Hannah. So that is why I've written it down. The minor segment lies inside the minor sector, while the major sector lies inside the major segment. Okay. Now I have to tell you how to find their areas. Basically, when you call them the major sector or the minor sector, That is because of the angle that they have at the center. Okay, so you look at this. If I uh, show you like this, so you see the sum, this angle at the center here. Now suppose this angle is 200. Okay, this is, no, this is not 200. This is, let's say it is um, yeah, this is 270 angle here. Okay, and this one is 90 degrees. So the smaller sector will have the smaller angle at the center, and the major sector will have the the bigger angle at the center. Okay. Acha. Now I have to tell you how to find the the area of the segment and the area of the sector. ठीक है बच्चों? So this is what our topic is: how to find the area of a sector. Let me take you back first. Now, if you want to find the area of a sector, that is simple, because a sector is a part, it is clearly a part of a circle. Okay, so the area of the sector actually depends on the angle that we have at the center here. Okay, so if this angle is, for example, let's say, let me draw one more circle here so that I can tell you about the half of the circle first of all. Okay, now suppose here it is the circle. Okay. Acha, now one more interesting thing. Do you know this region over here, the semicircle? Semicircle is a segment and it is also a sector. Okay. So I forgot to tell you here. If if sector and segment are equal, so this only happens when you have a semicircle. Okay, that is between these two. This is really interesting. Okay, acha. Now going to go back. The area of this semicircle is basically half of pi r square. This is half of pi r square. And if you have to find the area of the quarter of a circle, so that is basically going to be like this and then this. So that is quarter of this is quarter of pi r square. Now this is half pi r square. Basically, we can also write it as 180 over 360 into pi r square. क्यों बच्चों? This can be written as 180 over 360 into pi r square, because here you have the angle which is going to be 180 degrees here, है ना? And here you have 90 degrees. So this quarter pi r square can be written as 90 over 360 as well. 90 over 360 of pi r square. So in general, if you have a theta over here, so this is going to be theta over 360 into pi r square. That is how you find the area of a sector. This is the area of a sector. So area of a sector mainly depends on two things. One is the radius of that sector. Secondly, how big is this angle? Okay, bigger is the theta, bigger is going to be the value of the area of the sector. So area of a sector is area of a sector. Let me write this again. That is going to be theta over 360 into pi r square. Okay, bacho, area of a sector is theta over 360 into pi r square. Now, every year, either you are doing O-level mathematics or you people are taking your IGCSE, you will have a question on area of the sector and area of the segment. Both will be tested in your examination. So please listen to me very carefully and try to learn these formulas by heart. Okay, so now the area of a sector is no problem for you. You can simply, for example, if I give you a question here that, look, this angle is let's say 100 degrees and the radius is, let's say, that is 12 cm. So you have to find the area of the sector. You can easily say, look, this is going to be 100 over 360 into pi r square, and then you can use your calculator. This is the area of the sector. Now the problem arises when you have to find the area of the segment. Okay, you see mensuration where you have to plan a lot. Now, if you have to find the area of this segment over here, so you can see that this is clearly area of the sector, okay? Area of the sector, okay? And then you will have to minus, you'll have to minus area of the triangle. Let me name this triangle OAB, area of triangle, okay? Area of sector, and if it is the minor sector, by the way, okay? If it is the minor sector, then this is going to be minor segment, okay? So the area of the minor segment is going to be area of the sector minus area of the triangle. And please use that formula for the triangle. Now, let me write it down here. This will be 100 over 360 times pi r square, okay? And then minus half into 12 into 12 into sine 100. Now, this is the formula for the area of a triangle. Please learn this formula. That is half AB sine theta. If you have a triangle like this, you have this side A, you have this side B, and you have the angle between these two sides. So you can quickly find the area of the triangle through this formula. So, bacho, area of the minor segment is area of the sector minus area of the triangle. Now, what if you have to find the area of the major segment? For example, you want to find the area, like instead of finding this area, suppose you had to find, let me draw this line again. Uh, yeah. Okay. Now, suppose, bacho, you had to find area of all of this segment over here. So how would you do that? How would you find that area? So for that purpose, you first of all need to know that what is this angle here. So that is going to be 260 degrees. Okay. So this black area over here, black shaded area, is going to be area of the major sector, area of the major sector. And then will you add the triangle into it, or you would subtract the triangle from this?
Add, add.
You will have to add the triangle into it, okay? So for the major segment, for the major segment, this is going to be area of the sector, because we can find area of the sector quickly through this formula, but there is no direct formula for the area of a segment. Please remember that, okay? So area of the sector plus area of the triangle, okay? So you look at this, this would be, now you can write it down as, again, the angle of the sector is going to be 260 over 360 times pi into the radius, which is 12, okay? 12 square, and then plus area of the triangle, half into 12 into 12 into sine of this 100. The angle of the triangle is still 100. You can change that, okay? So that is how you can find the area of the segment. Okay, guys? So I'm giving you some questions here. You try them. So here are the problems. You have to find the area of the shaded regions here, okay? Okay, here the shaded area is representing the minor segment. Okay, so the area of the minor segment, first of all, you always need to write on the formula in mensuration. Okay, so in this first part, the shaded area is going to be area of the sector minus area of the triangle. Okay, so this will be 60 over 360 times pi into 10 square minus half into this 10 into 10, and you have the inclusive angle in here, okay? Half into 10 into 10 into sine 60. Just put in all this in your calculator and find this in just one step, okay? Because this is normally a paper 2 question, so you have to use your calculators for this. So by using the calculator, you can get to the value of this, okay? If someone has found it, please tell me, I can note it down here.
Is it question number one का answer?
Yeah.
9.05
So this is
centimeter.
9 point, correct to three significant figures. If he has used calculator correctly, then this should be the right answer. Okay, now I'm going to take you to the second question here. In the second part, you only have to find the area of the sector. Look at this carefully. This is the major sector, okay? So this second part, there is no addition, subtraction to take place. You only have to see that this angle has to be 250 degrees. That you have to determine, okay? So this area is going to be 250 over 360 into pi into the radius that is given as 7. So just put that into your calculator. Don't try to show any cancellation here. Write all of this in your calculator. 250 over 360 into 49 pi. So what is the answer of this?
Just answer it.
250 over 360 into pi into 49. Yeah.
250 over 360
Yeah. And then into 49 pi.
into 49. 106.90.
107 centimeters square, because we have to write this correct to three significant figures. Okay, now look at the third part, bacho. In this third part, you have to find the area of the major segment, okay? So that would mean you will have to know what is this angle here, that is 210 degrees. So again, you need to plan, you need to write all the formulas you're using here. So this time it would be area of the sector plus area of the triangle, okay? So area of the sector is simply just write it neatly, correctly, 210 over 360 times pi r square, radius is 11. And then you add the triangle into that. There is half into 11 into 11. I can write it as 11 square. And then there is going to be sine 150. That is the area of the triangle. And if you use your calculator, you can write your answer here. Okay, I'm not going to write that. Okay, and then if you look at this fourth part, that is just like same as the first part. In this fifth part, when you have to find this shaded area, this is the area of the minor segment here. Okay, so carefully you have to look at the diagram. So you need to see that, okay, this was A here and this was O over here. So you need to know what is the angle inside here. Okay, so this angle is going to be 160, because you need the angle of this minor sector. So this would become a question like the first part. Okay, so that is it from my side, where I have told you how to find the area of a sector and area of a segment, how to distinguish between the minor sector, the minor segment, the minor sector, the major sector, the minor segment, and the major segment.